the problem can be written as that maximum of z equal to y1 and subject to constraints. We make three constraints. First one is uh, y1 plus y2 minus omega less than equal to 0. So y1 plus y2 minus omega less than equal to 0. Second constraint we make from second constraint, that is y1 plus 2y2 minus omega, y1 plus 2y2. So y1 plus 2y2 minus omega less than equal to 0. Third constraint we make on the basis of uh, denominator of the objective function, which is y1 plus y2 given in the above. This is equal to 1. So here we use three variables, that means y1, y2 and omega. All three are greater than equal to 0. So this is our problem, that we after reducing the given problem. Reducing means given problem in the form of the fractional fx upon gx. So just we remove the fraction from the objective function we by using Karan-Cooper method algorithm. So we reduce in this form. Now we see that two inequality, that means first and second objective function constraint having less than equal to problem. So we make equal to by using the select variables. So that means this problem we consider as the linear programming problem. So now we write introduce S1 and S2. S1 and S2 as select variable. S1 and S2 as select variable, and this problem having equal to sign. So we introduce the artificial variable, and A as artificial variable. A as artificial variable to make inequality in equality. So when we introduce select, that means first constraint S1 select, that means we write in this form plus S1, that means LHS part is less than the RHS part. So something we add in the LHS part we make equal to. Okay. So we add S1 in the first constraint and S2 in the second constraint. We write as Y1 plus Y2. The procedure we use here as procedure. That means just you remember the Karan-Cooper method. So on the basis of Karan-Cooper method, that means this is the Karan-Cooper method. We eliminate a fraction from the objective function. So after eliminating fraction from the objective function, we make in the linear form, that is linear programming problem. So after linear programming problem, that we have the same solutions by using simplex method or by using a two-phase method, Wiggum method. Other methods are applicable. So we see that which method is applicable, we use the method. So this means plus S2 equal to 0, and third one we see that y1 plus y2 plus omega, that means here we write as A. So that means we take cost as minus A, artificial variable cost as minus A equal to 0. So cost of the artificial variable we consider as minus A. sorry, this is 1 equal to 1, third one equal to 1. The cost of artificial variable, because we use the artificial variable in this problem, so we cannot use the simple simplex method. We can use the BIGAM method or two-phase method. So we use the two-phase method. Artificial variable, cost of artificial variable is -1. So here we take the cost of artificial variable minus by using two-phase method. When we use by BIGAM method, so we take cost as -m. You remember this by using two-phase method. So you know that when we apply the two-phase method, that means other variable cost we take as 0. We take only the artificial variable cost. So for finding IBFS, initial basic feasible solution, so we put y1 equal to y2 equal to omega equal to 0. So this means S1 gives us 0. So S1 equal to 0, initial basic feasible solution, S1 equal to 0, and S2 equal to 0, A equal to 1. So these are the IBFS, that means value of B. And we consider cost of artificial variable is -1 by using two-phase method, and other variable cost is 0. We write here other variable cost is 0. So we construct a table which is, so when we construct the table of simplex method, so we take B as basic variable, and CB is the cost of the basic variable, and XB the value initial basic feasible solution, and variables Y1, Y2, omega, S1, S2, A, artificial variable A. So we construct, you all you noted this, Meenakshi, Dipanshi? This one all you noted? Okay. So this is CJ, cost of the variable. So we take cost of variable y1, y1, s2 all are 0, because cost of select variable we consider always 0, and the cost of artificial variable take -1 by using the two-phase method, and taking -m by using the BIGAM method. But here we use the two-phase method. So basic variables, so we put a basic variable as S1, S2, and A. 3 variables are in basic. That means 2 are select, 1 is artificial. And cost of the basic variable S1, S2 is 0, and A is -1. And the value of XV's value is 0, S1 equal to 0. We here find X1 equal to 0, X2 equal to 0, and A equal to 1. And Y1. So we write the value of y1. Y1 means coefficient of 1, 1, -1, 1. So 1, 1, 1, 1, -1, 1, 0, 0. So this is our first row. For second row, 1, 2, -1, 1, 0, 1. 1, 2, -1, S1 is 0, S2 is 1. For third row, 1, 1, 1, 0, 0, -1. Sorry, 1, 1, 1, 0, 0, and 1. A, we take 1 plus A. So this is the first simplex table. Here we write the minimum ratio. Minimum ratio xb upon. So we write here delta z. So multiply cost into this. So 0 into 1 is 0, 0 into 1 is 0, 0 plus 0 is 0, -1 into 1, -1, and we add all three, 0, 0 plus 0 plus -1, so that means -1, and subtract from cost, which is 1. You know the formula? The formula of delta j we use here, Cj minus summation of Cb y. Cb yi. Yi means y1, y2, and omega 1, omega 2. So this formula we use here, Cb yi. In place of yi, that means I equal to 1, 2, then y replace as omega and replace as s1, s2 accordingly. So this is 1, and second, 1 and 0 into 1 is 0, 0 into 2 is 0, same as -1 into 1, this -1, and from subtract from 0, which gives us 1. And omega 0, 0, and this is -1, and again 1. Again 1. Fourth, 0, 0, 0, 0 minus 0, 0. Fifth, 0, 0, 0, and subtract from 0 gives us 0. Next, 0, 0, and -1 into 1, -1, and subtract from -1, minus plus 1, so this gives us 0. Okay, so here we use the concept, if delta j greater than 0, that means maximum 0. So for we solve this for delta j less than equal to 0. We solve, remember this, we solve this for delta j less than equal to 0. So here we see that 3 delta j having greater than equal to 0. So that means we can take any one of them as a incoming vector. So incoming vector, that means we choose first variable, first column as incoming vector. So this vector we choose as incoming. We solve for this. That means if all values of delta j less than equal to 0, then we can say that our solution is optimal. Otherwise we solve. So here we see that all three values are greater than 0. That means we solve this problem. So we all three value having same value 1, 1, 1. So we can choose any one of the column as a incoming vector. So we choose first as incoming vector. So this first column is incoming vector. So correspondingly, we divide xv by incoming vector, xv upon y1. So xv upon y1, 0 upon 1. This is 0 upon 1. So here we 0 upon 1 is 0. 0 upon 1 is 0. Not neglect. 0 upon 1. 0 upon 1 is 0. Second, again 0 upon 1. Again 0 upon 1 is 0. And third, 1 upon 1. 1 upon 1, which is 1. It is 1. So we see that in minimum ratio, you study about this situation. All you know, this situation is called Meenakshi. This situation is called when two minimum ratio are same. So such type of problem is known as the Bhavna, Meenakshi. When two minimum ratios are same, so such type of problems is known as, write in the chat box, Ankita. Vibha, in the simplex table, when two minimum ratios are same, then such type of problem is known as Meenakshi. So here we no need to solve the such problem. That means so problem means use this problem. This is known as the degeneracy problem. Degeneracy problem. So when two minimum ratios are same, then degeneracy occur. So such type of problem is known as the degeneracy problem. So we remove the degeneracy by using some formula or removing the degeneracy. But here no need to solve. Let me use the formula for removing degeneracy. Just you consider first vector as outgoing vector. First vector is outgoing vector. Both are minimum 0, 0. That means you choose first as outgoing. So outgoing in front of S1. This is S1. So you choose outgoing vector. S1 is outgoing vector. So S1 is outgoing vector. So we see that in incoming and outgoing in front. So that means intersection, which is 1. So this one having intersection. This means intersection means you draw the line from S1 and draw the line from Y1. So intersect the line. So that element is known as the pivot element. So this one is the pivot element. Now we proceed next table. So for pivot element making 1 and below other elements making 0. So here our pivot element is already 1. So just we apply the operations, that means subtract from second row to first row and third row to first row, making both element 0. For making both element 0, we construct again next table. For removing the degeneracy, you know that we have the formula minimum of xb upon y1 upon y2 and such formula we apply. You already study in optimization technique. So now we construct next table. All you noted this table, Shifali, Meenakshi. Raise hand, Ankita. Okay. So now again we construct VCV, XV, Y1, Y2. Omega S1. Cost 0, 0, 0, 0, 0, minus 1. Same cost we again consider. And the variable in basic y1 replace s1, y1 s2 and a. So the cost y1 obviously 0, cos of 0 and minus 1. xb, xb we write on the basis that means same equation we use because the pivot element is unity 1. So there is no change in the equation 1. So we write as 0, 1, 1, minus 1, 1, 0, 1, 1, minus 1, 1, minus 1, 1, and S2, 0, A, 0. S2, 0, A, 0. So you write as for calculation, that means this is the helping row. Helping row, we take this element, make 1, other elements we write, sorry, 1, 0, 0. And apply row, we note down both rows, 0, 1, 2, minus 1, 0, 0, 1, 2, minus 1, 0, 1, 0. Yeah, correct. Okay. Next is 1, 1, 1, 1. 4 times 1, 0, 0, 1. 1, 1, 1, 1, 1, 0, 0, 1. So these are the apply row. Apply row, just we make both element 0, that means this element 0 and this element 0, just we subtract from row 2 to row 1. So on subtracting, you can write as R1, R2 and R3, row 1, row 2, row 3. So we write as R2 for R2, R2 minus R1, R2 minus R1. 0 minus 0, 0. 1 minus 1, 0. 2 minus 1, 1. Minus 1 minus 1, minus minus plus हो जाए, that means 0. 0 minus 1, minus 1. 1 minus 0, 1. 0 minus 0, 0. And this one, 1 minus 0, 1. 1 minus 1, 0. 1 minus 1, 0. 1 minus minus 1, plus 2. 0 minus 1, minus 1. 0 minus 0, 0. 1 minus 0, 1. So this is our complete table. That means now we write as this, and here is minimum ratio. Minimum ratio we write as xv upon. So CV y1, 0 into 1, 0, 0 into 0, 0, minus 1 into 0. So 0 minus 0, 0. 0 into 1, 0, 0 into 1, 0, minus 1 into 0, 0. 0 minus 0 is 0. 0 into minus 1, 0, 0 into 0, 0, minus 1 into 2, minus 2. When you subtract from 0 is minus 2, gives us 2. 0 into 1, 0, 0, and minus 1 into 1, 1. So 0 minus 1, minus 1. And next is 0, 0, 0. 0 minus 0 is 0. 0, 0, and this is minus 1, minus 1, minus 1, and that means 0. So we see that which value of delta J having greater than 0. So that means 2. 2 is greater than 0. So this one. So 2 is a incoming vector. 2 is a incoming vector. So corresponding to that means we write as xb upon omega. Xb upon omega. So this is xb, this is omega. So 0 upon minus 1. So 0 upon minus 1. So when we divide by a negative value, obtain negative value, so we neglect always. So we neglect something upon negative. We neglect. We cannot take negative value. And again, 0 upon 0. 0 upon 0 make indeterminate form. We write also neglecting. So 0 upon 0, we neglect. Next, 1 upon 2. So this is 1 upon 2. This is 1 upon 2, which is the minimum value. So we neglect them. That means this is our outgoing vector. So here variable is outgoing vector. Artificial outgoing vector. Okay. So we eliminate from the table. That means next we make the pivot element. Which element is our pivot element? We see that this is incoming, this is outgoing, and this element 2 is the pivot element. So element 2 is the pivot element. Same, we make this element is unity and other element of this column make 0. So second, this is also 0, then we make this -1 is also 0. So now we make B, CB, XB, Y1, Y2, omega, S1, S2, no need to write A. So here when artificial variable removed from the table, that means our phase first is completed. So we use the phase second. So when we use the phase second, so we take the cost of the actual cost of the variables. So you just first you cover the write the basic variables, etc. So here basic variable y1, second s2, and entering omega. Third variable as omega. So cost, here we write the cost. So cost of both variables. That means we proceed phase 2. That means phase 2 means there are two phases in the method. We have to solve the problem. So in phase first, we take the cost of other variables as 0 and take cost of artificial variable is -1. When all artificial variable removed from the table, then we start the phase second. In phase second, we take the actual cost. We take the actual cost of the variables. So here, first we complete the table, then we write the cost of the variables. So now we make this element is 1, so we divide by 1. So we write 1 by 2. So this is 1 by 2, 0, 0, we write 0, 0, and 1, omega 1, minus 1 by 2, 0, minus 1 by 2, 0. So we remove last column, so there is no need to write. Just one second. So no need to change in the second row. That means because this element is already 0, so just we note down cost 0, 0, 1, 0, minus 1 and 1. So we write that means there is one change. So helping row, that means third row use as helping row. So 1 by 2 0 0, we make this element as 1 minus 1 by 2 and 0. And the apply row, there is one apply row. So apply row first we write as 0 1 1 minus 1 1 0 1 1 0 1 1 minus 1 1 and 0, maybe last element. Yeah, 0 1 1 minus 1 1 0 0 1. Yeah, we make this element as 0, so that means just we add, we consider as this is helping row, that means R3 is helping row and R1, so just we add R1 plus R3. So we write in place of R1, so R1 plus R3. So when we add 0 plus 1 by 2 gives us 1 by 2. 0 plus 1 1, 0 plus 1 1, minus 1 plus 1 0. 1 by 2, this gives us plus 1 by 2, and this gives us 0. So now when artificial variable removed from the table, so just we give the actual cost of the variable. So we see that what is the actual cost. So we see that the maximum z. So maximum z, that means having only one variable, which is y1. So y1, the cost of variable y1 is 1. Otherwise, other variable cost is 0. So that means we can write as 1 into y1 plus 0 into y2 plus 0 into omega plus 0, cost of select variable always taken as 0. So 0 s1 plus s2, and we take as artificial variable. So this is our maximum z. So here we write the cost of actual variable. So you remember this, the cost of s2 because it's a select variable. So the cost of x2 is 0, and cost of this variable is 1. That means y1 is 1. So again, here we write as cj. Cj means cost of this variable is 1, and other variable cost we consider as 0. So this is basically we start the phase second. Start the phase second because two-phase method divided into two phases. So this is the phase 2, phase second of the two-phase method. So when we remove the artificial variables, just we write the cost, actual cost of the variable. So now we calculate the value of delta J. We calculate the value of delta J. So when we calculate the value of delta J, that means 1 minus 1 into 1, and others are 0. So when we subtract from 1 gives us 0. 1 into 1 is 1, 0 into 0 is 0, and 0 0. So 0 minus 1 gives us minus 1. So we see that 0 0 0 0 minus 0 0. 1 by 2 0 0 0 minus 1 by 2 minus 1 by 2, and 0 0 0 0 minus 0 0. So we see that all delta J, we see that all delta J less than equal to 0. So then the solution is optimal. Solution is optimal. You remember this, some authors take delta J less than 0, some authors solve for delta J greater than 0. So I am doing this for all delta J less than 0. So don't confuse. We can do for both cases. So solution is optimal. So hence the value of y1, which is xb, y1 equal to 1 by 2. y1 is 1 by 2, and the value of s2 is 0, and the value of omega equal to 1 by 2. So we use these values, the values of xb, remember. So these are three values, and maximum z. What is the value of maximum z? So we have maximum z equal to y1, this equal to 1 by 2, 1 by 2. And our given problem, that means actual problem, is given in the form of x1 and x2, the variable our actual problem. So remember this, our actual problem in this form, that means x1 and x2 form, not y1 y2 form. So just we find out the value of x1 x2 variable. We find out the value of x1 x2 variable. So you put here, that means y1 equal to omega x1 and y2 equal to omega x2. So we write the value of x1. So that means the value of x1 we calculate as y1 upon omega. Y1 upon omega, this means y1 is 1 by 2 upon omega is also 1 by 2, gives us 1. And the value of x2 we write as y2 upon omega. So y2 is not in the basic. Y2 is not in the basic, so then we consider y2 as 0. So when the variable is not in the basic, we consider as 0. So y2 gives x2, y2 equal to 0, so gives us x2 equal to 0. And the optimal value, maximum z, optimal value, you can write maximum z equal to our objective function in this form, x1 upon x1 plus x2 plus 1. So x1 is 1, 1 upon 1 plus 0 plus 1 gives us 1 by 2. So we already write here 1 by 2. So this is the problem we solve by using both method. That means the first is Karn-Cooper method, and the second our simplex method. So hope you understand this problem. This is our main problem. We start the problem, that means first we apply Karn-Cooper methods. So by using Karn-Cooper method, in Karn-Cooper method we apply the transformation. For transformation we remove the fractional part from the objective function. So after removing the fractional part from the objective function, we apply the simplex method by using select, after plus variables, etc. So here we solve by using select and artificial variable by using the simplex method. That means simplex we use the two-phase method. Okay. So hope you understand this problem. That means this is our third problem. First problem related to Beals and Wolfe method. That means which is quadratic programming problem. And second we discuss dynamic programming problem. And this one is fractional programming problem.